Okay, let's review our exponents. So the very first rule is the product rule. Okay. And before we do that, let's come over to this. Okay. If you saw 2 to the 4th, this little 4 that's up here, this is what is called our exponent. The 2 is our base. The whole thing together is called a power. Okay, so now let's go back over to the product rule. So I look at this. Do you notice how the bases are exactly the same and there's multiplication in between them? If that happens, all we do is we add the exponents. Now, some of you may be going, how do you know you do that? Well, you can't always write it out. So a squared is the same thing as a times a. A to the third is a times a times a. So how many a's did you end up with? You ended up with 5. So anytime you have multiplication of two bases and their exponents, their bases are exactly the same, then you add their exponents. Okay? The quotient rule, quotient meaning that you have division. Now I'm actually going to write it over here as this. Not exactly sure why I wrote it the other way, but this is going to be the same thing, and that's going to be where you, not what I meant to do. You subtract the exponents, and some of you may be going, how does that happen? So this is a to the 6th over a squared. 2, 3, 4, 5, 6. And I have it over 2 of them. Okay? A divided by a is 1. A divided by a is 1. Well, how many a's are left? There are 4 left. Over here, power rule. Okay. So if I have a power raised to a power, that means that I multiply my exponents. So some of you are like, huh? So I'm going to take a to the 9th. 1, 2, 3, 5, 6, 7, 8, 9. And I'm going to write that out 3 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. And 1, 2, 3, 4, 5, 6, 7, 8, 9. How many do I have? I have 27 A's. You can always write it out. Negative exponent means we are going to move. That's the number one thing. You're going to move the base that has a negative exponent. And then you're going to make the exponent positive. Now, could I have moved this over a little? Yes. It's ridiculous. So all we do, right now it's in the numerator, it moves down to the denominator and you make it positive. That's it. Okay. So now the other rule is anything to the 0 power is 1. So I could put 5, 8, 3, 2. Oh, that's not a 2. That's a 7, but I'll make it a 2. 7, 9, 5. Raised to the 0 power, automatically 1. Okay, so that's what we're doing. So here I'm going to look at this. And the directions on this part are saying that they want you to they want you to write it. I should show this. Okay. It says to write each expression using exponents. Okay. So -7 How many negative 7s are there? There are 2. How many 5s are there? There are 4. Now, it says to multiply it out if the exponent is 5 or less. So this would be 49. This would be 625. 49 times 625 would get me 30625. Now this right here is what is called standard form. Okay? When you multiply it out, that's standard form. Okay, so we're going to come over here. So how many n's do I have? I have 2. How many p's do I have? 2. How many r's do I have? 3. And that's all you do. This next one, ooh, I have to make it smaller because look at all that. Ooh, I've got lots of stuff. So I'm going to start with negative 2. How many negative 2's do I have? I have 1 here, 2, and 3. So I have 3 negative 2's. How many 3's do I have? I have 1, 2, 3, 4. And then how many x's do I have? I have 1, 2, 3, 4, 5. How many y's do I have? 1, 2, 3. Okay? Negative 2 to the 3rd power is the same thing as saying negative 8. 3 to the 4th power is 81. X to the 5th, y to the 3rd. 81 times 8, negative 8. It's going to get me negative 648. X to the 5th, y to the 3rd. Okay, let's come down here. It says simplify, put in standard form if the exponent is 5 or less. Okay. So we can do it the long way and write 1, 2, 3, 4, and then one more. How many do we have? We have 5. Or we could have just done 4 plus 1. That would still get me 6 to the 5th. And 6 to the 5th is going to be 7,776. Next one. You could do it d times d times d, d times d. How many d's do I have? I have 5. Or you can add the exponents because the bases are exactly the same. Over here, this base and this base are not the same. You just multiply them. That would get me negative 12. I add the exponents because these two have the same base, so I add their exponents. And I get negative 12x to the 8th. Okay, okay. So negative 16 is exactly the same. So I add their exponents. So negative 16 to the 15th power. Over here, as I look at this base, I'm actually going to write it like this. Let's go ahead and write it like this, just so that it's easier to see. I'm going to put my x's next to each other, my y's next to each other, my coefficients next to each other. So I'm going to take 3 and I'm going to multiply that by negative 14, and I would get negative 42. I'm going to add my exponents because those are two different variables. So negative 42, x to the 5th, y to the 9th. Okay, this next one. I have a negative 2, a negative 8. Now this one I could write out like this also. Now, or I could have just seen that it has a coefficient and it has a variable. Either way. So 16, now remember there's an invisible 1 right there because there's one of them. So 1 plus 7, so that would get me 16m to the 8th. Okay. Coming over here. I'm going to put my coefficients next to each other. I'm going to put my variables next to each other. This would get me negative 6. Remember, there's an invisible 1 right there. So 1 plus 4, So that would get me to the 5th. Okay, my coefficients. And this has a 1 there. 3 times 3 times 1. I have to the 5th. This has an invisible 1. And this has a 4. So I multiply the coefficients together. That would get me 9. And I add the exponents. So 9y to the 10th. This one. My coefficients. -5 times 2. J squared times j to the 4th. K to the 5th times k. And that's to the 1st. M to the 4th. M to the 2nd. So -10. J to the 2 plus 4. K to the 5 plus 1. M to the 4 plus 2. So -10. J to the 6th. K to the 6th. M to the 6th. Okay. So this next part, we're doing the quotient property. So that means we're going to be subtracting the exponents, not adding the exponents, as long as the bases are the same. The bases have to be the same. Well, if I look first at these, those bases are not the same. So you just divide the numbers. The coefficients, you just divide them. So 8, we can even separate it if you want. Okay? And then we have this. Okay? If we separate it. So this is going to get me 4n squared. Now, if you want me to write it out, that's fine. I can do that too. 1, 2, 3, 1. Okay? So this gets me 4. That cancels out, and I get 4n squared. Okay, on this one, I have 1, 2, 3, 4, 5, 6, 7 over 1, 2, 3, 4, 5, 6, 7. Cancels out, that's 1. Cancels out, that's 1. Cancels out, that's 1. 1, 1, 1, and 1. So guess what? My answer is 1. Now, could you also have subtracted your exponents? Sure. I would have gotten y to the 0 power, and anything to the 0 power is 1. On this one, I'll separate it just so that you can see it. 1, 2, 3, 4, 5. 1, 2, 3. 18 divided by -9 is -2. Cancel, 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 and I get x squared. Or I could have done it 18 over -2 and subtract my exponents. So that gets me -2 x to the 2nd. Either way, it's going to get you the exact same answer. Okay, again, same thing here. 7 times 7 times 7 times 7 times 7 over 7 times 7. Cancels, that's 1. Cancels, that's 1. I have 7 to the 3rd power. And 7 to the 3rd power would be 343. Or I could have taken and subtracted my exponents, got 7 to the 3rd power, and it would still be 343. Okay. Next. -9 over -6. 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. Then we have 1, 2, 3, and we have 1, 2. Cancel, 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 cancel. Now I'm going to look at my coefficients first. Negative divided by a negative is a positive. Now, 6 does not go into 9 evenly, but 3 goes into both of those numbers. So I get 3 over 2. I get x, 1, 2, 3, 4, 5, y. So I'm going to do it over here. -9, -6. I subtract my exponents, and I still end up with the same thing. Now, the other way to write this, you could, because this is all over 1, you could write it like this. But either way is the exact same answer. Okay, let's go over here. I have negative 12 over negative 4. 1, 2, 3, 4, 5, 6. 1, 2, 3. Okay, negative 12 divided by negative 4. That will go in evenly, so I will get a 3. Cancel, 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 and I get x to the third. Or you could have just subtracted your exponents and gotten 3x to the third. Okay, let's look at this one. We have 5. Oh no. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. Whew. And that's over 20. And I have 1, 2, 3, 4. And I have 1, 2, 3, 4, 5, 6, 7, 8. Oh no. It helps if you read the direction. Oh, this only has 1 on the bottom. I tried to do the numerator. Sorry about that. Now, if I look at my coefficients, be careful. The bigger number is on the bottom. That means when I simplify this, this is going to be 1/4. It is not 4, it is 1/4. Cancel, 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 cancel. And I would get x to the 5th power. Cancel this, y to the 7th power. Again, this can be written as x to the 5th, y to the 7th, all over 4. It's the exact same thing. If I was to do the other way, 5 over 20, subtract my exponents, I would get 1/4, x to the 5th, y to the 7th. And guess what? Same exact answer. Okay, this one. Negative 3, 3, negative 3, negative 3, 3, negative 3, negative 3, negative 3. Cancel, cancel. So I'm left with negative 3 to the 4th power. Or you could have done the shortcut and just subtracted the exponents and gotten the exact same answer. Okay, let's look over here at number 9. Okay, I'm just going to simplify this. I subtract my exponents, remembering that that has an exponent of 1, so 3 minus 1, 12 minus 5. I simplify this fraction. What goes into both 8 and 12 evenly? 4 does. So I'm left with a 2 and a 3, x to the 2nd, y to the 7th. Or I can always write that like so. Okay, and last but certainly not least, negative 24 over negative 3. Subtract my exponents. Okay, this simplifies to 8, x squared, y to the 5th. Okay, the next one's a power to a power. You're going to multiply the exponents. So, it says 7 times 7, and we have to write that 3 times. How many 7s do we have? We have 6. So, the other way that you could have done this is just taken 7 and multiplied the exponents, and you still would have gotten 7 to the 6th. Okay. 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1. Okay, so how many z's are there? There are 28. 28 z's. You could have done it the rule way. Okay, I can't even write today. 7 times 4 and that would be to the 28th. They're the exact same answer. This next one, remember that this has an exponent of 1, boys and girls. So I have 2, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2, 3, 4, 5. 2, 3, 4, 5. 2, 3, 4, 5. I had to count how many I had. Okay, so how many 2's do I have? I have 6. How many m's do I have? I have 30. Okay, or I could have done it the rule way. I take the exponent of 1, I multiply my exponents. The exponent of 5, and I multiply by the 6. So I get 2 to the 6th, m to the 30th. Okay, next one. So on this one, that's to the first power. So I multiply the exponents, multiply the exponents, multiply the exponents. So 7 to the 4th power, a to the 20th power, b to the 24th power. So 7 to the 4th power, oops. 2,400. 1, a to the 20th, b to the 24th. Either one of these would have worked as your answers. Okay, now, -3, exponent of 1 times 5, w 3 times 5, z 8 times 5. So this is -3 to the 5th power, w to the 15th, z to the 40th. So to the 5th power, it's going to get me -243, w to the 15th, z to the 40th. And last but not least in this section, again, remember there's an exponent of 1 here. 3 times 4, 1 times 4. So x to the 12th, y to the 4th. Okay. Anything to the 0 power is 1. Negative exponents, you're going to move the base. So if I look at this first one, this has a negative exponent. The a does not. So this b is the only thing that's going to move. It's going to move upstairs. So I have b over a. This next one, right now it's in the numerator. It's going to move to the denominator. Remember, there's a coefficient of 1 right there. So it's going to be 1 over x. And if you'd like the little 1, that's fine. Over here, this is the only part that has the negative exponent. That is the only part that moves. This part right here is the only part that has the negative exponent. That's the part that's going to move. b over 3a. This moves and this moves. The 7 does not move. The 7 stays on top. The x moves to the bottom. The y moves to the bottom, and their exponents become positive. Okay, this one. This part right here, that's the only part that has a negative exponent. That's the only part that moves, and its exponent becomes positive. This is going to move downstairs. This is going to move upstairs. The 8 stays where it is. X to the 3rd, y squared. This moves downstairs. This moves upstairs. So the d to the 3rd is on top. 2 didn't move, and c. This one. Only thing that has a negative exponent. And I like it in alphabetical order. Over here, this part right here, again, is the only part that moves. The 9 and the B stay where they are. Okay, so now we're going to do some mixed review. This is multiplication right here, so that means we're doing the product property. So that means I add my exponents. So I get 7 to the 9th power. Okay, this is a quotient. Remember that there's an invisible 1 right there. So I subtract my exponents. I get 2 to the 4th power, which is 16. Here, it's a power raised to a power, so we multiply exponents, and I get 9 to the 6th power. Here, this is multiplication, so I add my exponents. This is a power to a power, so I multiply my exponents. Now, even though this has parentheses, there's no extra powers up here other than 1. There's nothing up there. So what's happening is we're actually multiplying these together. So I have 9 times negative 9, k to the 3rd, k to the 4th. So negative 81, k to the 3 plus 4, negative 81, k to the 7th. Next one, got multiplication going on here, so I add my exponents. Okay, that's 11. This one, it has parentheses. It has an exponent on the outside of the parentheses. That means this is power to a power. Remember that there are invisible 1s right there. So 2 to the 1, 1 times 5, q to the 1 times 5, so q to the 5th, 5 to the 5th, q, try that again, 2 to the 5th, q to the 5th, and that's going to be 32, q to the 5th. Over here, this is multiplication. There's an invisible 1. We add our exponents. This is a quotient. We subtract our exponents. Again, there's no exponent. This is just multiplication, so I'm just taking negative 5 times 5, x squared, and x to the 7th. So negative 25, and then I add my exponents. On this one, it's a power to a power. So I multiply my, I was writing the answer down. Multiply my exponents. This is also a power to a power. Okay, so negative 5 to the 1 times 2, x to the 1 times 2, negative 5 squared, x squared, so that's going to get me 25x squared. This one, I have negative 3 to the 1st power times 4, 4 times 4, 6 times 4. I get negative 3 to the 4th power, x to the 16th, y to the 24th. Negative 3, all raised to the 4th power, is 81. Number 15. Remember that's 1. So 4 to the 3rd, x to the 15th, y to the 6th, and that's going to be 64, x to the 15th, y to the 6th. Okay, now, doesn't have a set of parentheses on this side, but that's okay, it's still multiplication. Negative 6 times 4, x to the 3rd times x, y times y to the 5th. Negative 24, remember this has an invisible 1, so 3 plus 1. Remember there's an invisible 1, so 1 plus 5. So negative 24, x to the 4th, y to the 6th. Okay, on this one, 24 over 3. Remember there's an invisible 1. 4 minus 1, 9 minus 8. 8, x to the 3rd, y to the 1, but we don't usually write the 1. Okay. So this one, I have 4 over 12. Remember, this has an invisible 1. 2 minus 1. I think this is supposed to be a y. Change that to a y. 5 minus 5. Z, 8 minus 2. So the fraction becomes 1/3. X, y to the 0. Z to the 6th. Now this right here, that just turns to 1. So 1/3 x z to the 6th. And you can also write that as x z to the 6th all over 3. Okay, next. I look at this, the whole set of parentheses is raised to the 0 power. Anything raised to the 0 power is 1. And then this one has a negative exponent. It moves upstairs, so negative 7 x to the 10th over y to the 4th.